So in 12.1, we're learning how to classify, how to identify solids. We can't find surface area and volume of a solid that we don't know what it is to start with. So here's the good news. For those of you who don't like showing work, your homework doesn't have anything to do with math, really. You're not calculating anything. All you're doing is classifying. What kind of figure is it? Classifying the solids. All right, in example 1, we're learning what these types of solids are that we're going to be learning this chapter. We have pyramids, prisms, cone, sphere, and cylinder. Write those 5 down. Pyramid, prism, cone, sphere, cylinder. Let's talk more specifically about each one of these. Okay, so a cone. A cone has one circular base. All right, you can think of it like an ice cream cone. All right, one circular base. A cylinder has 2 circular bases. And a sphere, you could say, is like a 3D circle. So like a basketball or a baseball or, anything like that that's, 3D, we would say is a sphere. All right, so those are your definitions. Those are really cut and dry. It's a cone, a sphere, or a cylinder, or it's not. Now, once we get over to pyramids, though, pyramids and prisms are classified by their bases. So they could all look very different depending on how many sides are in their base. And so on a quiz or a test, you can't just say, oh, it's a pyramid or it's a prism. You have to actually classify it by its base. So if it has a 3-sided base, let's review for a sec. What's a 3-sided polygon? A triangle. So I would call it a triangular pyramid or a triangular prism. If it's 4-sided, it would be rectangular. Probably it could be a square, but without any dimensions, we're going to see. And then we got 5-sided. So a 5-sided polygon is a pentagon. So I would call it a pentagonal pyramid. All right, because these are adjectives describing what kind of pyramid. So we kind of put that AL suffix on the end, pentagonal. All right, so kind of going along with that theme, down with prisms, let's just kind of keep going up the side. So 6-sided would be a hexagonal prism. What about 7-sided?
No, that's
heptagonal. And 8-sided would be a octagonal. Okay, so these are where do I get this from? I get it from the base. How many sides are in my base? Okay, that'll tell me what type of pyramid or prism it is. Here's the difference between a pyramid and a prism. Are you ready? A pyramid, all of the sides form a vertex or a peak at the top. A pyramid, think about the pyramids in Egypt, okay? It forms a peak at the top. Prisms don't have that. Prisms have 2 identical bases. Pyramids only have 1 base. All right, but here's what's the same about them. They are both completely formed. All of their sides are polygons, okay? Whether it's a pyramid or a prism, they're polygons. All right, so those are some of the similarities and differences between pyramids and prisms. All right, now, example 2. Let's look more specifically at types of pyramids. All right, so they're all pyramids. Why? Because they all have a vertex, right, at the top. So these are all pyramids, but now I'm going to look specifically at the base to determine what type of pyramid it is. If all you say is pyramid, it's wrong. You have to tell me what kind of pyramid it is. So let's look at the first one. Yes, since we don't have specific dimensions, we're going to assume that it's not exactly the same. So it is a rectangular pyramid. Rectangular pyramid. So that would be wrong. All right, so now I've labeled the figures 1 and 2. Obviously, you're not drawing these figures on your paper, but I want you to try to write on your paper what type of pyramid is figure 1 and what type of pyramid is figure 2. You're going to classify it based on the number of sides in the base. What did you say for the first one? Triangular pyramid. What about the second one? Pentagonal pyramid. Pentagonal pyramid. Okay, pentagonal. All right, so there's 5 sides. All right, so now let's look at example 3, still example 2, but now instead of pyramids, let's look at prisms. All right, so now remember, prisms have how many bases? 2. They have 2 identical bases, so that's how you can figure out. Okay, so like on example, or in the first one right here, on this one, the figure is almost on its side. It can be deceiving to think that maybe this side right here is the actual base, but it's not. That's only one. What is the actual base of that figure? The triangles. The triangles here. This is, yeah, that's the actual base. So you got to think, there's a triangle, there's a triangle. Prisms have 2 bases. All right, so since the bases are triangles, yep, it's going to be a triangular prism. You don't add a lot. Triangular prism. No, you just look at the shape of the base. Okay, so I want you to do figure number 1 and figure number 2. What type of prism? How do I know it's a prism? Because it has 2 identical bases and obviously has no peak like the pyramids. So on the first one, how many sides does the base have? It's 8. It's octagonal. Octagonal. What about number 2? Hexagonal. Okay, guys, noise level. Keep it down. Yes, number 2 was a hexagonal prism. Did y'all get both? Okay, very good. All right, so that's kind of how we classify. All right, remember, specific. If it's a prism or a pyramid, you have to tell me what kind. Cone, sphere, cylinder. It's just one of those. Okay, there's nothing specific about those. All right, now let's look at example 3. In example 3, we're looking at faces, edges, and vertices. What does that mean? A face is a side. Okay, a face is a side. So here, let's just kind of highlight it. This is a face, the front side. Well, if a cube has a front, it also has a back. If it has a right side, it also has a left side. If it has a top, it has a bottom. So top and bottom, right and left, front and back. 6 faces. Okay? 6 faces. Now your edges, all right, so we've kind of highlighted the different faces. Your edges are where the faces meet and form an edge. That's why it's called an edge. So where the faces meet. So the edges, let's look. Here's my top one. 1, 2, 3, 4. Okay, there's 4 edges around the front, so guess how many's around the back? There's 4 on the back. Now, what about the right and left?
2.
There's 2 on the right and 2 on the left. I only count the edges once. I've already counted 2 of the edges when I did the front and back, so there's 1, 2, 3, 4 on the right and left, so 4 plus 4 plus 2 plus 2, 12 edges. Then the third thing is what we call a vertice or a vertex. Vertice is plural, means more than one. A vertex is where the edges meet, the point where multiple edges meet. All right, that's a vertex. So how many vertices do I have on the front?
4.
How many do I have on the back? 1, 2, 3, 4, 5, 6, 7, 8. 8 vertices. Nope. There's just 8. There's 8 points where the edges meet. So there's your vertices. Okay, so now I want you to look at this figure and I want you to tell me how many faces, how many edges, and how many vertices are in this figure? How many faces?
4.
There's 4. There's a significant point.
There are 1, 2, 3, 4, 5. Yep, there's 5. Why? Because the bottom. The bottom. So from each side there extends from each side of the base there extends a side. So there are 5 faces. How many edges?
8.
3, 4, 5, 6, 7, and 8. Very good. How many vertices? 1, 2, 3, 4, 5. All right. Did anybody get all 3 right? Okay. If you understand that, that's everything you need to know for 12.1.